Hi. In a series of videos, I'm going to discuss confirmatory fact analysis, path analysis, and structural equation modeling. A confirmatory fact analysis technique is a method that helps you validate your questionnaires, your tests, or other modes of assessment using a quantitative analysis. In confirmatory fact analysis, we generate latent variables, we use observable or observed variables, and then we hypothesize the connections between the latent variables and those observed variables. In the same way, a path analysis or a structural equation model is also used for validating theoretical frameworks, but the difference is that you can actually use path analysis and structural equation modeling to validate cause-effect sort of relationships. Of course, that's also a subject for arguments, because some people argue that SEM or structural equation modeling does not necessarily indicate cause and effect. I think that's a topic for another video. The software packages that I'm going to use include AMOS and JASP. Most likely, if I find time, I will also show you how to use Literal, which is also another powerful package for structural equation modeling and confirmatory fact analysis. JASP is freely available, so you can download it from the website. I'll try to leave a link to the website where you can download JASP. AMOS is not free, and therefore you have to make a payment in order to be able to use it. But the good news is that you can download a trial version of AMOS from SPSS website or IBM SPSS website. I'll try to leave a link in the comments section there for you to be able to download AMOS as well. So I will start from AMOS, and I will show you how to go through different stages of developing a CFA or a confirmatory factor analysis model, and how to get the fit, and how to make sure that your data is valid for the purposes that you want to use. Then I will talk about path analysis and structural equation modeling. I assume that these will need several videos, and I hope you will be patient enough to watch the videos. And if you have any questions at any time, feel free to leave them in the comment section. I'm happy to get back and answer your questions. So let's get started with AMOS. So I'm going to start by discussing how to use AMOS for confirmatory factor analysis in this presentation. You can download AMOS from this website. You see downloading IBM SPSS AMOS version 26, and the version that I'm using for this presentation is also version 26. I will provide this link to this website so you can download the trial version of it. I also mentioned that there is another software package called JASP, which can be downloaded from here. I will also leave this address in the comments section below so you can download it. For this video, I'm not going to use JASP, I'm going to use AMOS. So I've already opened my AMOS here. The data file that I'm going to use is this one in SPSS, and it actually has a few variables here, 4 variables. It's a listening test which was administered a few years ago. The first section, the scores of students on the first section are here: section 2, section 3, section 4. For this presentation, we're going to hypothesize that sections 1 and 2 contribute to the measurement of one latent variable, and sections 3 and 4 measure a different latent variable. I'm going to tell you what I mean by latent variable and measurement in a second. I also assume that the data is normally distributed. The assumption is actually supported by the analysis of normality. In previous videos, I have discussed how to investigate normality, so I'm not going to go through this. I will leave the relevant links in the comment section again. If you're interested to find out how to investigate normality, I highly recommend that you take a look at those videos. It's particularly important because if, for example, you want to publish your research paper in a journal, it's important for you to present evidence that your data was normally distributed. There are two types of normal distributions: univariate and multivariate normality. You can look into univariate normality in SPSS, and also for multivariate normality you can get some indications in AMOS itself. So I'm going to go to the AMOS interface, like this part here, and you'll see the interface is in my opinion quite user-friendly, because it's like it has been designed for click and go sort of analysis, so it makes everything easy for us. One of the first things that I need to do in order to start the analysis is to open the data set. So I go to this box here, to this icon here, which is called Select Data Files. I click it, and this window pops up. Now I need to find my file. So I go through the available files here on my computer. I've already created this folder for my data. It's actually the SPSS data set that I just showed you. So I'm going to click this and open. It's important to make sure that your data the name of your data file can be observed here, as well as the number of cases. Always make sure that these two are there, and that's one way to validate your data. So then you can click OK. Now your data has been read by AMOS most likely, and what you can do at this stage is to just check if your data is open or not. So this button here provides a list of the variables in your data set. Click it, and yes, our data set has been read. You see section 1, 2, 3, and 4. So I'm going to close this. Now, like I said, I hypothesized that there are two latent variables. So I click on this button here. It's called Draw a Latent Variable, or add, or what's the other one? Or add an indicator to a latent variable. So what I'm going to do is to draw two latent variables. So I click on it. When you click on it, you see it's activated. It's changes the color around it, shows that it's activated. So that now you just put the cursor on the main interface and click to get the first variable, and do not move outside of this circle. Within the circle, click once or twice, as many times as necessary. Here I'm going to click twice because I need two observed variables, 1 and 2. So you see my these two, 1 and 2 boxes are basically the observed variables, and this circle represents the latent factor or the latent variable. But there are also two arrows out there, and actually there are two smaller circles which are connected, but you cannot see it from here because they're falling outside of this interface. So I'm going to minimize this interface a little bit like that, so that you can see this. The other thing you could do is unclick this first, then click this preserve symmetries. So you just activate it and click this car icon to move objects around. So once you click the car icon, it is actually ready for moving the objects around here. So everything can move together. But if you do not activate this button here, which actually preserves symmetries, you see only the object, that single object that you click on, moves around like that. So this might make your shape a kind of asymmetrical or ugly. So I recommend that you always make sure that this is active if you want to move around the whole model. So I already got this. The other thing that I need to do is to create a similar kind of representation for a second measurement model. By the way, this is called one measurement model. I will explain that in a second. So let me just show you a very easy way, because my second model is going to be exactly like this. I don't have to go through the same process, 1, 2, 3. This is, well, another way of doing it, but I'm going to do Control Z and undo everything that I have done. The other way is to click on this open hand sort of icon. Okay, you see everything changes into blue. This means that everything that you have in this window has been selected. Now, next is you can duplicate exactly this model. You can click on this duplicate objects and put the cursor on the model, on any part of the model. Really doesn't matter because everything has been selected. Click and move, and you got it. You got a second model. Then don't move it anymore, because the more you move it, the more duplicated models you'll get. So I'll just go back here, click this, and as you see, there are still, actually unclick it. So as you see, these options are still blue. That means they're active. What I need to do is to close it. That's deselect all objects. So I deselected, and that's it. So I have two similar, almost, I should say, two same models here. What I would need to do is to move section 1 to this variable and section 2 to this variable. Section 3 here and section 4 here. Just drag and drop, really, like, it's exactly the same way that you do in Windows. And close this. Now this is a bit small. I'm gonna zoom in a little bit, so that's too much. So you can see what's going on here. Okay. Now I have circles, and let me draw some lines here for you to clarify what I mean. I have two circles here. These two are called latent variables or latent factors. Latent variables or latent factors are actually the main cause of these guys, these 4 observed variables. And these 4 observed variables are you have already seen them before. There are those 4 observed variables which we saw in the SPSS file. We also have these smaller circles. Actually, they must be a bit smaller than this. It's like they're out of proportion with the rest of the variables. But these smaller variables, which are actually error terms, that's the amount of variance in the observed variables which is not explained by the latent variable. So that's the error term. We would like the error terms to be small, but the amount of variance that is explained by the latent variable here, we would like it to be large, as large as possible. Now I would like to clean everything and go back to naming these variables, because they need to have names. We can't just leave it like that. There is a very easy way to name. I go to plugin and go all the way down to name unobserved variables. Everything which is represented by a circle, small or big, doesn't matter, will be named immediately. So that's it, we got it. E1 stands for error 1 all the way to error 4. Now F1 is factor 1, F2 is factor 2. You can double click on each of these variables, or actually everything here, and here, and here, and here, to change the name of the variables. Instead of factor 1, I would like to say listening 1. Try not to leave a space between the words, because AMOS doesn't accept that. I think that's the default of AMOS. So listening 2. As you see, these names are quite general. Really, you can name it anything. It doesn't matter. It depends on your theoretical framework. So that's it. Then I actually change these names as well. It doesn't matter, you can call them anything, but you see every time you click on this, the name appears here. Then on this, you don't have to close this pop-up window. That's a good thing in AMOS, so it makes everything easier. The other thing is that you can change the font size, because this font size is small, isn't it? So I can change it to, let's say, 23, then 23, 23, and 23. Okay. A few more things before we start the analysis. First of all, notice that these arrows run from the latent factors to the observed variables, to your test items. Okay. One of them, there is a little one, if you notice here, just beside this, beside the arrow, and that's called a regression weight. It's we have to fix one of these regression weights to 1 or anything else for parameter estimation. So make sure you will have this. If you don't have this, then AMOS will not run, and you will get an error message. So whenever you have a latent variable, which is indicated by observed variables, make sure that at least and at most, only one, I should say, only one of these variables is only one of the regression weights of the variables is fixed to 1. The other thing is that these two measurement models are not related to each other yet. I need to create a relationship between them. So this relationship that I'm going to define here is covariance, and I'm going to represent it by a two-headed arrow. So I click on this draw covariances, and then I move from one side to the other, and then I got it. So this means that there is a relationship between the model for listening 1 and the model for listening 2. Now, the model for listening 1 is, this is one of the models, is one measurement model, and the other one is another measurement model. The relationship between these two measurement models is in the form of a covariance. This means that our model is a confirmatory factor analysis. So a confirmatory factor analysis model only includes measurement models like this. But if instead of this two-headed arrow there was a one-headed arrow, like this. Let me just erase this. By the way, you can click on this erase objects icon and choose the line or the variable that you want to erase and click, and that will be it. Make sure you will not erase the variables that you need. You go back here, unclick it. What you can do is, for example, define a cause-effect relationship like this. It means listening 1 has an influence on listening 2, or some part of the variance in listening 2 is attributable or attributed to listening 1. In this case, since listening 1 is being predicted by listening 2 is being predicted by listening 1, you will also need to add an error term there. You go back here to add a unique variable, and you click on it. You see, you have already added an error term. It's not very beautiful, so you can keep this icon on this latent variable and keep clicking to move it clockwise, like this, like this, like this, like this. Okay, so you can just, keep moving it clockwise. I think this is good enough for me. Now this is another error term. Actually, since the error term is linked to a latent variable using this arrow, this is typically known as a disturbance. So what I'm going to do is to change the size of this disturbance or error term here. I unclick this and I go here to the menu, change the shape of the objects. I click on it. Go back here, and I can reshape it. It could be larger, you can make it larger or smaller. In this case, I want to actually make it smaller, like this. And then I go back to
the truck icon and then move it further ahead so it will fall within the interface.